Hey there, welcome to a quick note. Today, we're delving into the enchanting world of snow and uncovering the secret behind its beautiful whiteness. Ever wondered why snow looks the way it does? Stick around as we unwrap the science behind it. We all adore snow because it turns everything into a beautiful, pure white cover. We often refer to snow as the white stuff in weather forecasts, and during December, the song White Christmas plays repeatedly. It might sound strange that snow is white when it's basically a bunch of ice crystals clumped together. So, why is snow so brilliantly white? To figure that out, let's take a step back and understand why things have different colors in the first place. So where does color come from? Visible light is like a team of tiny dancers, each moving at a different speed. These dancers represent different colors that our eyes can see. When light meets particles, like atoms or molecules, it makes them jiggle. How much they jiggle depends on the speed of the dancers, or the frequency of the light. Now, when these particles jiggle, they can absorb some of the dancer's energy. It's like they take a dance break and store that energy. Later, they release this stored energy as heat. Here's the cool part, different particles prefer to dance to specific frequencies. So, they absorb certain colors more than others. The colors that aren't absorbed keep dancing through. In some materials, when a particle shares the dance energy with its neighbor, the light just keeps traveling through. That's why these materials are see-through or clear. But in most solid stuff, the particles hold onto the dance energy and don't let much light through. So, the object becomes opaque, meaning you can't see through it easily. The color of the opaque object is like a mixtape of the light that the particles didn't absorb. Let's uncover the reason behind snow's distinct whiteness. Even though snow is essentially frozen water, which is usually clear without impurities, it manages to look white. To figure this out, let's focus on a single piece of ice. Unlike being see-through or transparent, ice is more like a semi-transparent or translucent material. What this means is that when light tries to pass through it, the particles in the ice don't let it go straight through. Instead, they play a little game with the light, changing its direction. This happens because the distances between some atoms in the ice's molecular structure are similar to the height of light wavelengths. Picture it like this: the light photons, those tiny particles of light, interact with the structures inside the ice. As a result, the path of the light photon gets altered, and when it exits the ice, it's heading in a different direction than when it first entered. Now, imagine a whole bunch of these individual ice crystals coming together to form snow. When light enters a layer of snow, it encounters an ice crystal on top, which gives it a little nudge and changes its direction. Then, it moves on to the next ice crystal, which does the same thing. This bouncing around and changing of directions by the light inside the snow structure collectively create the appearance of whiteness that we see. So, snow isn't inherently white, it's the result of all these playful interactions with light within its icy structure. Exactly. The magic behind snow's whiteness is like a bouncing light party. The crystals in the snow play with light, making it bounce all around until it comes right back out of the snow pile. This bouncing effect happens to all the different colors of light, so they all get bounced back out. Even though the individual ice crystals might not look white, when you combine all the colors of light together, you get white. It's like mixing all the colors in a rainbow and ending up with a pure, snowy white. And here's a fun twist: depending on how the sun shines on it, or if it's in the shade, or if a furry friend leaves a mark, snow can look a bit bluish white, pinkish white, or even yellowish white. The National Center for Atmospheric Research points out that sunlight and shadows can make snow appear different shades. Plus, if snow has some algae in it, it might show off a reddish tint. Nature's way of adding some unexpected hues to our winter wonderland. And there you have it, folks. The mystery of why snow dazzles in white, unraveled right here on a quick note. If you enjoyed this quick dive into the wonders of nature, don't forget to give us a thumbs up and subscribe for more intriguing nuggets of knowledge. Until next time, this is a quick note, signing off. Stay curious.